little resistance, it is a little thicker. That is what is called viscosity. So that we'll study in the chapter in detail, but since the formula is there, so let us see. F is
Ma'am,
the force.
coefficient of viscosity?
What?
Coefficient of viscosity?
Yes. This is the coefficient of viscosity, right? This is the coefficient of viscosity. This symbol is actually pronounced as eta. So coefficient of viscosity is this. A is the area, dV. Now, you have studied symbols like minus, plus and all. These are very common for you. Like in class 11th, you people are already aware of all this. You have differentiation and integration that we'll study after this chapter, before the starting of the motion in a straight line. So you will see, whenever there is a change between two quantities, and that change is finite. For finite change, you will see this symbol, delta. A triangle will be made. In chemistry also, you will see. In physics especially, you will see. Finite means like when I say 5 minus 2, let's say 5 meter is one distance, 2 meters is another distance. So 5 minus 2, that is finite. But sometimes you have very small changes that are neglected in mathematical algebra. If I give you a very small number, like let's say 0.000000, so many zeros, and I just put one like this. So when we have to add it, when we have to subtract it, we'll say answer is 0. Who is going to add all these zeros and up to these many places? And addition will also not allow you to add it. So see, there are certain cases where your algebra fails and you need to apply the calculus part. So how to apply the calculus part and all, we'll see later. But just since the symbol came, so that's what I'm telling. This D symbol, this delta is for finite. And this D symbol is when the change is very small. For that, you have this dV and dx. Like when we're talking about the fluid. So things are very small changing. You don't see the fluid moving like this in front of you. Right? So for that purpose, we have. Now, in your dimensions, it's not going to affect you. Okay, this is not going to affect you. You know the dimensions of velocity, that's it. That is sufficient for you. So F is equal to eta A dV by dx. dV is the velocity, dx is the thickness, A is the area, F is the force. So let's see, F is equal to eta A dV over dx. Now our task is to get the coefficient, the dimensions of the coefficient of viscosity. So like a normal equation, we'll shift all the variables here and there. So force was already here. We'll multiply it with distance. This thickness will go here, divided by, look, area into dV. This will come in the denominator. So area into dV. Now our task is just to put the dimensions.
Ma'am, dx is change in infinite?
Yes, change for infinitesimally small quantity. Yes, this is
And
all.
then v is for the small change.
V is, see, the symbol D is for the very small change. But when I say dV, it means small change in velocity. When I say dx, it is small change in thickness. Okay.
Okay, so x means thickness and v means velocity.
V is the velocity, yes. So see, in every question, it can be different. In this question, the question has mentioned that take dx as the thickness. And throughout, you will feel when you have the chapter going on, you will feel that all the variables are mentioned. Even in your entrances, your NEET exam, the variables are mentioned for this particular chapter. Okay. So eta is F dx over AD. Now forces. Yesterday we discussed that force is mass into acceleration. Mass into acceleration is LT to the power minus 2. So this is the force. Okay. So revise the table. We'll start with another table today. So 24 more quantities are left that we'll complete. Some quantities are left. Dx is the thickness. So class, from the fundamental table, can you tell me thickness, which variable should I write? Thickness. How do you measure thickness? So dimension should be similar to mass, time, length, current. For thickness of something. Thickness of a book, thickness. Check. Yes, Aisha, what do you think? Aisha?
Mass.
No, not mass, length. Thickness is always represent. Thickness is actually the length. If I ask you how thick is your book? So you will not tell me its area or volume. You will tell me, yeah, the book size is let's say 5 centimeters. So it is very thick like this. Thickness is always given in terms of length. Now area, we did it yesterday. Area, can you tell Fatima?
Area, it is L square.
Yes, very good. This is L square. And Aisha, can you tell for velocity? Look, you must have written yesterday.
Yes, LT raised to the power -1.
Yes, very good. LT to the power -1. Gradually, with your practice, try to remember few things, like which I have made you mark so that this will ease your calculation. Look, force, velocity, these are the things only I made you remember. Now see, this is now a simple question. This length will cancel this length. This length will cancel one more length, right? So we will be left with M. This L will go up. L to the power -1. And look, this is -1. When this goes up, it becomes 1. 1 minus 2 is -1. So these are the dimensions. Am I clear, Fatma and Aisha?
Yes.
Yes.
Write it down, then we'll continue with some more quantities that can come. Please write it. And just update me in the chat box, so I'll store it.
Done.
Done?
Yes.
Okay.
Yes.
So the way we did these quantities, no, these 7 quantities, let us continue from the 8th one. Because some quantities are there. See, every question we cannot do. It's better if we do it in a tabular manner. So angular displacement, let me just brief you with it. Now, this is from your rotational chapter. Angular displacement basically means we have studied the distance and displacement, that is if a body is moving in a straight line. Angular displacement means, see, if this is a body and it has covered like this, a motion like this. Many times you have quantities that cover motions like this, especially in your rotational chapter. So right now, there is some angle that is swept by the body. This is your angular displacement. Now, formula of angular displacement is whatever you've studied in your mathematics. Formula of the length of the arc and the radius of the arc and the angle of the arc. Formula is that. But see class, length of arc. Length is directly L. And what should I write for radius? Which quantity? What do you think? M, L, T, A? Radius. Length. Correct. Length. See, check the units whenever you're getting confused. Radius, you write it as, okay, 3 meter, yeah, meter, so length. So this is length. Now class, length is getting cancelled. Mass is not present, time is not present. Then m to the power 0, L to the power 0, T to the power 0. You don't have anything. So basically, this is a dimensionless quantity. It is a dimensionless quantity, but it is a quantity that has a unit, as we discussed yesterday. This SI unit is radian. So class, whenever you get a question to mention a quantity which is dimensionless but has an angle, but has a unit, always mention angle or angular displacement. You can simply write angle also and angular displacement. Then you have angular velocity. Now, angular velocity means this angular displacement divided by time. So yes, class, angular displacement is dimensionless. Time is simply t. So when this t will go up, it will become only t to the power minus 1. Now, angular displacement is, your angular displacement is, just a second, class, please. So yeah, I was discussing that your angular displacement is dimensionless. It doesn't have any dimensions. M0, L0, T0, all the dimensions are 0 straight away. So when you are getting the question for angular velocity, it is getting divided by time. So time was time inverse. Let me share the screen first. Yeah, is it visible?
Yes.
Okay. So this is radian per second. Now you have this angular velocity t to the power minus 1 divided further with time. So that is, see, this is time, this is further getting divided by time. Look, time, when will it go up? It will become t to the power minus 2. And this unit will become radian per second square, like this. So see, your task should be, class, you should have this with you. If you are given this, you should be able to write this. Nobody should be able to help you in this. You should be so fluent with the dimensional formula that you should be able to write all these formulas. Is that
Ma'am,
clear?
explain the angular velocity again.
What will be?
Angular velocity dimension.
Angular velocity, that's what I've written, t to the power minus 1. Look, angular displacement by time. Angular displacement is dimensionless. It is L to the power 0
Ma'am,
divided by time.
if it is L to the power 0, then why are you taking L here? It means nothing but 1, right?
Yeah, L to the power 0 is 1. That's why, see, in the final formula, I'm not getting anything. I can take L to the power 0, T to the power 0, M to the power 0. I can take 3 of them. But there is no point of writing it. Right? It is 1 only. L to the power 0 will give us 1 only. This I just wrote because I am just putting the step by step, I'm putting the formula. That's it. If theta is L to the power 0, so I'm just putting L to the power 0 to show you that, yes, see, this is how we are getting T to the power minus 1. You're right, Fatima. L to the power 0, any variable to the power 0 is 1 itself. Okay.
Okay.
So write it till here, then we'll see other quantities.
Ma'am, angular velocity is represented by small w.
Yes, yes. This symbol, this is also actually called as omega only. One was
Okay.
that symbol that I told yesterday, but this is represented. You can write it as W.
Okay. Done, ma'am.
Okay, see, moment of inertia, what is it? See, these are all terms from your rotation. Just understand, whatever quantity you study in normal linear motion, it has an analog in your rotation. Like your force, whatever is the function done by force, forces become torque. Like force is not responsible for rotating the blades of the fan. Torque is responsible. So like this, whatever function mass does, mass becomes your moment of inertia. Linear momentum becomes angular momentum. Like linear acceleration became angular acceleration, linear displacement, angular displacement, linear velocity, angular velocity. Similarly, these are also analogs. But again, our task is to write the dimensions right now. You have individual separate chapters on all of these. Now, mass. For mass, we should write it as m r square. What should be written?
L square.
Yes, very good, Fatima. L square. So this is ml square. Now, unit is kg and radius square is meter
Yes.
square. Correct. Kg meter square. Now, torque is radius in force. Aisha, can you try this one? For radius, what do we write?
L.
L, correct. And force is?
MLT raised to -2.
Yes, correct, Fatima. mlt to the power minus 2. So see, this becomes ml square t to the power minus 2. So we get, this is Newton meter. So this is basically whatever the function force is doing in your rotation. Coming to angular momentum. Angular momentum is radius into linear momentum. So radius is length. Linear momentum was mass into velocity. Check. You must have written, right? Yes or no?
Ma'am, momentum.
Yeah, you must have written momentum. P is the symbol. P is equal to m into v.
Yes.
Yes. So that is mass into velocity. So this is it. So this becomes ml square t to the power minus 1. And see the unit. Momentum was kg meter per second. Yesterday you have written this for momentum. In linear momentum, radius is getting multiplied. So kg meter square per second. Is it clear till here, till the 13th?
Yes. Yes.
Okay, write it.
Done, ma'am.
Both of you?
Yes. Yes.
Okay. Let's continue further. Okay, class. This at least you both answer me in the chat box. Stress. Stress, this is from your solids now. Mechanical properties of solids. We are jumping into book 2 now. So stress, strain, whatever things are important that can come. This is that table only. So at least all of you answer fourth one. In the chat box, tell me the answer. Then I'll discuss it. Okay. Okay, let's check now. Match your answers. Both of you have given. See, force is mlt to the power -2, not -1. Acceleration, mass into acceleration, okay? Divided by L square. So this becomes m. Now see, 2, this L becomes -1, t to the power -2. Yeah, Aisha is correct. I think Fatma did the mistake here in this. She took it this as -1, right? Okay, no issues. So SI unit is Newton per meter square, or you have one more unit that is called as Pascal, which we discussed in pressure. Yes, same as that of pressure. Formula is also the same. See, force per unit area was the formula of pressure. Then you have strain. Strain means whatever change is coming. Like if I have this pen and I'm extending it. So whatever was the original length and whatever the change has come, suppose it has increased this much. So change in length by original length, but in dimensional analysis, see, both will be having the formula of length only. So L to the power C. Now look class, this is a dimensionless quantity again. One was our angle, second is this. But class, here this is unitless also. There is no unit for strain. So if you get a question, write down the quantity which has no dimensions but has a unit. So that will be angle. Mention the quantity that has no dimensions, that has no units. Then you will use strain. These are very two good examples to write in the exams. Now you have the third question, modulus of elasticity, which is the ratio of stress and strain. So basically, whatever is the formula for stress, we'll have exactly for the modulus of elasticity. Look here, class, strain is 0. Strain has no dimension. So whatever are the dimensions of stress will be exactly of the modulus of elasticity. So this is ml to the power -1 t to the power -2. Strain is nothing, it is 0, ml, m0, l0, t0. So you just get this term as it is, ml to the power -1 t to the power -2. Units will also be the same since this is unitless, no unit for strain. So directly you will write this as Newton per meter square. Then you have surface tension. Surface tension basically means the topmost layer of fluid when it is present. It is in a state of tension, means all the molecules are trying to contract on the top surface of this. That is what is surface tension. So formula is very easy. Force is mlt to the power -2. length is L. So basically here length gets cancelled. So mt to the power minus 2. This is surface tension, which is force per unit length. So this is from your fluids. Now from the chapter waves and oscillations, you have few quantities: wave, time period, and frequency, these three. So wavelength is basically the length. So directly length and meter. Wavelength means, see, when a wave is moving, before it starts to repeat itself again, that length is called wave. Time period means how much time is taken by the wave to complete one full wave. So this will also be P, which is in second. Now, the rest of it I'll discuss later. First, copy it till here.
Done. Ma'am, can you show angular displacement?
Which one, Fatma?
Eighth one. Done, ma'am. You can scroll down.
Okay. Let us continue this. Yeah, I was talking about frequency. Frequency is also a term from your waves only. Frequency basically means, see, in 1 second, how many waves are flowing? So 1 upon time period, that will be t to the power minus 1. So its units are seconds inverse, or you have one more unit. Hertz, like this we write Hz, hertz. Then there's one quantity that is from your class 12 that can come because of frequency. That's why I've written this. Otherwise, the 12th class quantities have not included. E is basically for energy. H is the Planck's constant, this term. And this new symbol, this is the frequency. So basically, this is a very detailed part. So this, let me just tell you in brief. When a metal surface is there, you will study photoelectric effect in your chemistry. So that time it will be clear to you. In class 11th only you will study, and then you will have this whole thing in class 12. Basically, when a metal surface is there, it has electrons in it. When a light falls on it of suitable frequency, the electrons come out of the surface. So this whole process is called photoelectric effect. In that whole equation, in that whole process, Einstein gave an equation. He said that the energy is directly proportional to the frequency. So whenever you have the proportionality sign and you want to remove it, what do you do in maths? You put an equal to with a constant. That constant is basically the Planck's constant. So again, we are concerned with energy divided by frequency, because Planck's constant will be energy by nu. So this energy, I told you to remember the energy, the dimensions of work done. So because for all the sorts of energies that are present, you will have the same dimensions as that of energy. Work done, kinetic energy, potential energy, internal energy, any kind of energy in the system. So energy will be, so this is work done. We write it as force into displacement. Now ml square t to the power minus 2 divided by frequencies t to the power minus 1. So this will become ml square t to the power minus 1. And SI unit, this is joule seconds. Now, temperature is fundamental in nature. Fundamental I have written. So its dimensions are theta or K only. This is from your fundamental table. So it is fundamental, no need to derive it. Now heat energy is, whether it's heat energy, it will be same as that of the work done only. So that is m L square t to the power minus 2. Energies, SI units are joule, same as that of work done. You know the CGS also for that. CGS only till the first table you should remember. That's why I have separated them. Those are important for CGS. Now till here you can just see the SI. Now coming to this specific heat, this is something important, specific heat. Specific heat, basically, this is from your thermal physics. You will study this in detail. Delta Q is basically the heat energy. M is the mass. S is the specific heat, and delta T is the temperature change. So from here, what will S be equal to? It will be delta Q divided by M into delta T, right? S is missing. Now let's put the values. Delta Q is the heat energy. Energy will be exactly the same. So ml square T to the power minus 2. M is the mass. Temperature, change in temperature. Temperature is delta theta only. So this will become, look, mass gets cancelled. L square T to the power minus 2, theta to the power minus 1. Okay. And look, this will be energy is joules per kg per Kelvin. Okay. So this is actually from your second book. So see, don't worry about the formula and the meaning of everything. Just know that if this is given, you should be able to write this. Is that clear?
Yes.
Okay, write it, and if you still have any doubts, anyone, you can let me know. Please write it.
And what will be the SI unit for temperature?
For temperature,
Yes.
it is Kelvin. We have written in the fundamental table. Okay.
Then the Done, ma'am.
Okay, class, let us look at now one different kind of question that comes from your dimensional formula. The basic calculation, this variable is missing, calculate the dimensions. We have seen two questions. Now we discuss the theoretical part. Let us come to another question which is based on the principle of homogeneity. Now pay attention first, both of you. Principle of homogeneity. See, if I give you a situation, if I ask both of you, what is 7 kg plus 2 centimeter? What's the answer to this? 7 kg plus 2 centimeter. Is there any answer to this?
No.
No. See, you can never add kg with centimeter. If I had asked you, what is 7 kg plus 2 kg? 7 kgs plus 2 kgs. You would have directly told me the answer that this is 9 kg. You wouldn't have hesitated the way you hesitated for the first part. If this would have been 7 centimeter plus 2 centimeter, you would have told me this is 9 centimeter. Same is for subtraction. If I ask you 7 kg minus 2 centimeter, you will not be able to do this. But if I ask 7 kg minus 2 kgs, you'll tell me, yeah, it is 5 kgs. So what is there? What is the principle behind this? You can add only those quantities that have the same dimensions, class. Okay. See, you can, if you cannot add 7 kg plus 2 centimeter, it is because this is having the dimensions of mass and this is having the dimensions of length. If two quantities are able to get added, or we are able to, if two quantities are able, we are able to add these two quantities, or we are able to add these two quantities, or we are able to subtract these two. Basically, it is the reason holding is that they have the same dimensions, and this is what is called as the principle of homogeneity. Now, in this question, it has asked us to calculate the dimensions of A and B. F is force, dimension is also mentioned. A and B are some constants, x square is mentioned, B. Now class, if I am able to write A minus x square, it means these, whatever is the dimension of A, whatever is the dimension of x square, they are the same, then only they are able to get subtracted. Do you agree, both of you?
Yes.
So it means this says, this can conclude as the fact that dimensions of A, this is exactly same as the dimensions of x square. Then only we are able to subtract them. So dimensions of A will be x is position length, x square will be L square. So dimensions of A will be L square. So L square, that's why it was getting subtracted with this L square. This is clear, A?
No, but how did you conclude it will be length only?
How did we convert it into length? No, we are writing the dimension. See, we are writing the dimensions. Dimensions can be anything. Dimensional quantities are based on your mass, length, and time. You're not defining A. You're not defining or writing its meaning. You are just seeing whose dimension it is similar to. So it must have the unit like meter square. It must have been something. So one thing that we conclude that A minus x square was given in our question. This we didn't take by ourselves. So definitely if they are able to subtract, they are able to get subtracted. This means they both have the same dimensions. So if x square, x is L, x square will be L square. So dimensions of A will be L square, not the physical meaning or the actual meaning of it. Is that clear?
Okay, ma'am. So basically from the question, you understood it is length, so that's why you just put that like in that side of the equal sign and
Yes,
then you
if
got
it
L
is
square.
addition or subtraction. Not with
Okay.
multiplication division. Multiply and divide we do. If I asked you 2 kg by 2 centimeter, that you would have told me that it is 3.5 kg per centimeter. Totally in physics, we have been using from our first class yesterday. We have multiplied it and divided the quantities. But in addition and subtraction, the same thing is not followed. So if it is getting added or subtracted, you directly write. Now, for
Okay.
B, look, the question. This is a minus x square by bt. Now, force we know, b we have to calculate, t is time. For a minus x square, you don't have to write L square minus L square class. Look, when you have 7 kg minus 2 kg, does it get cancelled away? No, you still have the units kg only. Means if this is m, result will also be m. So if this is L square, this is L square, their resultant will also be L square. So instead of a minus x square, I can still write this as L square. Got it?
Yes.
Aisha, did you understand?
Yes.
Okay. So because it's like when you have added it, when you've written 7 kg plus 2 kg, you don't write 9 kg square or something. You write kg only. Despite this addition, we write the same dimensions. So for a minus x square, you can write this as L square. So see, this is F is equal to a minus x square divided by bt. Now force we know, B we have to calculate. A we have already calculated. Now a minus x square, this whole complete term, a minus x square will be L square only. You don't write this as L square minus L square class. Otherwise, you'll get the answer 0 every time. And you will be stuck with it. Because you don't actually subtract the dimensions. We are not solving some algebraic formula that we can write L square minus L square, it gets cancelled and it is 0. This is not algebra. This is the dimensional calculations. So force is mlt to the power minus 2. A minus L square, x square is L square by b. Now time is simply t. So from here, see, for addition and subtraction, you just had to be careful. Now you can simply multiply and divide. So b will be L square divided by mlt to the power minus 2, and this is t. So b will be m to the power minus 1. This length will be cancelled. So this will be L. 1 minus 2 is minus 1. So this is t. So b is m to the power minus 1 LP. Clear?
Yes.
Fatima?
Ma'am, the T you multiply, right?
Where?
From the denominator went to numerator, so
Yeah, they
you
are getting multiplied. See, t to the power minus 2 multiplied to t to the power 1. When bases are same, powers get added up. Exponents. So 1 minus 2 is minus 1. And when that minus 1 goes, see, this is
Oh,
minus 2 is minus 1. When this minus 1 goes up to the numerator, it becomes plus 1.
okay, ma'am.
Okay, write it, try to analyze. If you still have difficulty, let me know. Okay, please write down this question.
Okay. Then